Okay guys, let's take this question. So this question is on dimension analysis. The question says, for which of the underlisted quantities is the derived unit ml squared t minus 2 correct? Roman figure 1 says moment of the force, Roman figure 2 work, Roman figure 3 acceleration. Now to get this question correctly, let us find the dimension of each of these quantities that are listed. So the first one is the moment of the force. So moment of the force, the formula for moment of the force is force times perpendicular distance, basically force times distance, basically. So now we need to break each of these quantities down. We need to break them down to their simplest mean. Now distance does not have any formula. Distance is a fundamental quantity, all right, but force is a derived unit. We need to break down force to its fundamental unit. So the formula for force is equal to mass times acceleration, all right. So now let us input that. So moment of the force is going to be mass times acceleration times displacement. Now mass is already a fundamental unit also, but acceleration is still not a fundamental unit. So the formula for acceleration is equal to velocity over time. Change in velocity over time to be more specific, but velocity over time is enough for this case. So mass, moment of the force rather, is equal to mass times velocity over time times displacement, all right, times distance rather. Now mass fundamental, time fundamental, distance fundamental. Velocity is still a derived unit. We still need to break down velocity to its fundamental parts too. So velocity is equal to distance over time, displacement over time. So moment of a force now is equal to mass times displacement over time times distance. All right. So now this is equivalent to mass times displacement over time squared times distance. Okay, so moment of a force is equal to mass times displacement over time squared times distance. So this is also equivalent to mass times distance squared over time squared. Now okay, so the dimension of mass is m, dimension of distance is l, that's the L squared, and the dimension of time is t raised to power minus 2. So this is what we were asked to find. So this is the derived unit that we were asked to find. So it means that moment of a force, actually it means that the dimension for moment of a force is ml squared t minus 2, which was what was given in the question. It means that Roman figure 1 is correct already. Now let us verify for Roman figure 2 now. So for Roman figure 2 now, we've already established that the dimension for moment of the force is ml squared t minus 2. So let us verify for Roman figure 2, which is the so the formula for work done or work basically is force times distance. And if you notice that the formula for moment of the force is force times perpendicular distance or force times distance, work also is force times distance. So we don't need to go through the stress of verifying it again. Since they have the same formula, it means they are going to have the same dimension, which is ml squared t minus 2. All right. So it means Roman figure 1 tallies with it. Roman figure 2 also goes with it. Now for Roman figure 3 now, let us confirm. Roman figure 3 is acceleration. What's the formula of acceleration? Acceleration is equal to change in velocity over time. So this is basically what's velocity. Velocity is also displacement over time. So acceleration will be what? Displacement over time, which is displacement over time squared, which is lt minus 2. So that is definitely not what we are asked to find. It means acceleration is not part of our answer. So the correct answer is Roman figure 1 and Roman figure 2, and that is option D. So I hope you understand the concept. That's it. Thank you.